This is sample problem 7F on page 256 of your textbook. And it says a spinning ride at a carnival has an angular acceleration of 5/10 radians per second squared. And it wants to find the tangential acceleration of a rider who sits 6.5 meters from the center of the ride. So here is our given information. Okay, we have, remember, this is small case alpha, that's acceleration, angular acceleration, 5/10 radians per second squared. Our radius is 6.5 meters. This now is tangential acceleration, and that's what we want to find in this case. We want to know what the tangential acceleration is. So here is our equation. Tangential acceleration is radius times rotational acceleration. And remember, they can give you anything. They could give you the tangential acceleration and our angular acceleration, and you could find the radius. So in this problem, it works out nice because they give us these two parts, the right side of our equation. So all we're going to do, I'm just going to plug those values in. Our radius is 6.5 meters, and our angular acceleration, 0.50 radians per second squared. All right, and now when we multiply these, we get, it actually comes out to be, if you multiply this, and we do 6.5 times 0.5, we get 3.25. But we only want two significant figures, because when we multiply, we take our smallest amount. So with our two significant figures, 3.25 is going to stay 3.2, because remember the 5 in significant figures wants to round it to an even number. And I know your book says 3.3 meters per second squared, but that's not what we're going to do. It's 3.2 meters per second squared if we keep the proper amount of significant digits. Their rounding process was off by a little bit. So that's how we go about finding tangential acceleration. And again, depending on what they give you, use this equation. You can be able to find any part. They'll give you two, and you can find the third part.